In this section, we're going to talk about marginal cost and marginal revenue again, but now in the context of when marginal cost, or I'm sorry, when cost and revenue are not lines, like we talked about in chapter 1, and now that we have this idea of a derivative. So when we were talking about marginal cost before, we had cost or revenue were linear functions. And when that happened, we were told in chapter 1 that marginal cost and marginal revenue were the slopes. And how we interpret that is that it was gives us how much more our cost would be if to produce one more item. And now what we're going to talk about is if we are dealing with nonlinear functions. So sometimes revenue will still be linear, but cost will be nonlinear. Maybe they're both nonlinear, and or maybe they're both lines, and we have to go back to chapter 1. But we have the idea of the nonlinear functions, which happens a lot in the sense that depending on if you can buy in bulk, that's going to change how your cost changes once you can start buying your products in bulk. And then after a certain point, you might need to add hours, pay your employees more. You might need to start adding more employees. You might need to add more storage space. Lots of different things can go into how the curve might be nonlinear. Likewise with revenue, it might be nonlinear if you sell it at bulk prices. Oh, now you have free shipping. All of that can go into changing what the revenue and cost look like so that they would be nonlinear. And using this idea, we have that when they're nonlinear, we have marginal cost that we will shorten with marginal C, is the derivative. And I'll use Q for the quantity of items producing. Likewise, marginal revenue is going to be the derivative of your revenue function, because we still are thinking of slopes, but in nonlinear, the best we can do is right at that moment, what is the slope of the curve right at that moment? And that would be the slope of the tangent lines. And so what these can interpret is these give us estimates, that both of these estimate, right, when they're nonlinear. When they are linear, they give us exactly how much the change in cost or change in revenue would be, but they estimate the change in cost or revenue, depending on which one you're looking at, when you increase Q by 1. So to see a formula that you might see in the book, our marginal revenue at, say, I'll write it with actual numbers. Our marginal revenue at 250 gives us an estimate of the difference in revenue between selling 251 and 250 items.